So, in this video, I would do these exercises and walk you guys through these. So, let's get started with 313. So, 313 is in the textbook if you guys want to follow along or do it yourself. But, yeah, you could see what's going to ask you, but this one's asking you just for the critical points. So, let's just start doing it. So, again, what we do, we find the partial derivative to respect to x and y, right? So first of all, let's kind of observe this. We have x here and x here. We don't have an x here, so we just observe these first. So partial, right? X just equals 2. So minus 1, and bring this here. So 45, right? 45 x squared, right? Then minus 3y. Another one we have respect to y, we get negative 3x, then right here 3 times 15 is 45. The minus 1 to the power is 2, right? So you got minus 3x plus 45 y squared. And to find the critical points, we set both equations to 0, right? So what I would do first is use substitution, right? We have x here, y here, and x here, and y here as well. So let's find for y, and this would be the easiest equation to find y from, right? So we have 45x squared, right? We bring this over to make a positive, equals to 3y, right? Then divided by 3, this also divided by 3. 45 divided by 3 is what? 15. So we have y equals 15x squared. Now, let's use substitution and plug it in into this equation, right? So we have negative 3x plus 45, and we have y equals 15x squared, so 15x squared over 2, 2 to the power of 2. So overall we have negative 3x plus 10125 to x to the fourth, because we have 45. So we do this first, find this, then we multiply it by this, and just we get our value. Now still equals 0. So this, as we see, we now have x's here and x's here, so we could bring out the x, right? So x of negative 3 plus 10125 to the third equals 0. So we know that this could be 0, because anything times 0 would equal 0, right? So we have x equals 0, and now we find this. We go within the parentheses and find and make that 0, right? So we got negative 3 plus 10125 x cubed equals 0, right? So what do we do? Do 10125 x cubed equals 3, right? Then to make x alone, we divide it by 125, right? So that would just make it x equals to 3 of 10125, right? To the 1/3 power to get rid of the cube from the x. So overall we have x equals 1/15, right? So now we could plug these values into what do we have for y. So first let's do the 0 on y equals to 15 times 0 squared. That would just be 0. And y equals to 15 times 115 squared, and that would just equals 115. So overall, we have two critical points, which is 0, 0, and 1 over 15, and 1 over 15. Now, let's do 318, and in the textbook, it states that we have to use a second derivative test to classify any critical points and determine whether each critical point is a maximum, minimum, a saddle point, or none of these. So 318. So what do you do first? Right? We find the partial, right? With respect to x and with respect to y. So let's do that first. We have here as an x, here as an x, and none of these have x's. So we look at these. So we have negative 3x squared. Then right here we only have plus 4y. And right here we have just no x, no y here. And we have y here, but not here. So we get 4x, and we have negative 4y. And seeing these will make our life easier, right? Because we can just use this system of equations to figure out the critical points easily. So what we do is, since these are the same, right? How do you we could subtract it, right? Or add it, we could just add it. So overall, this goes to 0, and we're left with negative 3x squared plus 4x equals 0. Now we only have a common variable, which is x, and what we could do is pull it out. So we have negative 3x plus 4 equals 0. Again, since x is outside, anything times 0 would equal 0. So x equals 0. And we focus on this within this parentheses. So it's negative 3x plus 4 equals 0. Then put it here to make it positive. So we have 3x plus 3x equals 4. Overall, we have x equals 4 thirds. So this is our two critical points for x, right? Now we plug it into an equation of y, right? So an easiest equation we could do is this one. Since we could just do this. We're testing for 0 and we're testing for 4 thirds. So we have 4 times 0 minus 4y, which is equals, so we have 0 minus 4y equals 0, right? Then we just, do 4y equals 0. Then 4 divided by 0, 0 divided by 4 is y equals 0. Another one, we have another point is 4 thirds, right? So we have 4 thirds minus 4y equals 0, right? So that would just equal 16 thirds minus 4y equals 0. Make this positive sign right here, so we put it on the other side. So 16 thirds equals 4y. And we divide by 4, and we divide that by 4. So we get y equals 4 4/3. So our critical points are 0, 0, and 4/3 and 4/3. Now we would have to figure out if these points are saddle points, local mins, or local maxes. But before we do that, we have to find the second derivative of the partial to respect to x and y, right? So first things first, we have this as our first partial. So what do? We don't see any x's here, so we look at this one. So negative 3x squared, what's the derivative of that? So it'll just be 2 times negative 3, right? So that's negative 6. This one is 2y now, right? So that would just be nothing here, and right here, so that would just be negative 4, right? And finally, we have f x, y. So now we're looking at the x partial with respect to y. So this is not with respect to y, and this is, so that would just equals 4. And now we set up the Heisen matrix, but we already know the equation for that, right? So it's be d equals 2 negative 6x times negative 4 minus what? 4 squared. Let's plug in 0. So let's find at 0.00, right? We have negative 6 times 0 times negative 4, right? Minus 4 squared, right? So overall, 0 minus 16. So d is less than 0, right? So if it's less than 0, remember rules, that would be a saddle point. And finally, we test the points 4/3, comma 4/3, right? We have d is equals to 6 times 4/3, right? Times negative 4 minus 16, right? So what do we get? We get 32 minus 16. Oh, we forgot this. Negative 6 times 4/3 times negative 4, which is 32, and minus 16, right? So that's equals 16. So our discriminant is greater than 0, right? But looking here, our partial to f of x, the double one, is less than 0, right? Because you could tell by this negative, so it'd be less than 0. So therefore, if discriminant is greater than 0 and the double partial is less than 0, that would give us at 0.4/3 local maximum, right? So we did this one, and we did this one, and we'll view the next 3 next videos because I don't want this video to be too long.